Are you guys ready for the holiday? Or all of it? Let's look at section 2.3.2, the row reduction. So you're looking at the properties of determinant. Properties of determinant. So we'll start from the row reduction. Now, we want to look at how when we have the elementary matrix, after reducing the matrix completely, then we definitely get a matrix which is a triangular matrix. So before we do an example here, let's write something small here. So row reduce the matrix inside given determinant to an echelon form matrix. We'll reduce, then note that every n by n matrix, or every n by n echelon form matrix is an upper triangular matrix. So once you reduce the matrix, then what you get is an upper matrix. So it means you have zeros below the main diagonal, and the upper one, there are some values or some entries which are not zero. Example number one. Example number one. If we let E to be a 4 by 4 elementary matrix, we remember what an elementary matrix is. So this is where we perform the row operation of the identity matrix. Now, if let's say we have the row operation here, and then we have the elementary matrix E here, and then we have the determinant of E here. Now, a 4 by 4 match identity matrix is a matrix which, like, it has, let's say, 1 0 0 0. So 1 2 3 4 0 1 0 0 0 0 1 0 0 0 0 1. So that is a 4 by 4 identity matrix.
Now, if we do the raw operation in this matrix, let's say we take this R2, the new R2 here, to be, and then we add or we subtract 3R4. Okay. So if we want to get the new R2 here, then let's subtract this R2 here by 3R4. So that means this is row 1, row 2, row 3, and then row 4. So to get the new R2, then we take this R2 and then we minus 3R4. So definitely our elementary matrix will now be the first one will not change. The new R2 now will be, because we are taking this R2 minus 4 minus 3R R4, then this will be 0, 1, and then 0, and then we have minus 3 here, since the R4 here is 1. So the other ones will still remain the same. This is 1. Now, what will be the determinant here? So determinant, we, using the previous theorem, determinant we get by doing what? Multiplying what? The leading or the main diagonals. So the determinant here will be equals to what? Will be equals to 1, right? Because it will be 1 multiplied by 1, 1, 1, all of it. Now, if we switch R2 and R3, if we switch R2 and R3. Now, let's say we switch R2 and R3. This R2 to come down here, R3 to come here. So what we get is our elementary matrix will now be 1, 0, 0, 0. We are switching R2 and R3. So 0, 0, 1, 0, 0, 1, 0, 0, and then 0, 0, 0, 1. Okay. So once we switch, then we switch R2 and R2. Now this is not the diagonal matrix, so we cannot multiply this. So we do what? We can now come and look at the one which has many zeros as possible. Like, for example, we can just take one. So we can just ignore all this, and then you just take one. This, right? We can just take this. 0, 1, 1, 0. Okay. So if we take 0, 1, 1, 0, then what will be this? What will be the determinant? It will be 0 and 0 minus what? Minus 1. So the determinant will be what? Minus 1. So the determinant here would be minus 1. Okay. So you can just take this.
Is there any positive one to minus 1?
No, it is this and this is 0. Minus 1 minus 1. So 1 and 1. So 1 multiplied by 1 is, so it is 0 minus 1 multiplied by 1 is minus 1, right? Yeah. Oh, you can take, you can do what? You can use the cofactors. So if you use the cofactors, you just, let's use this, okay? If we use this one, then we delete this and this, okay? So we can delete this and this. So it will be, when we delete this and this, okay, wait. yeah, we can delete this and this. So that means it will be 1 multiplied by -1. And then this is the second row plus 1, 2, 3, the third column. Okay. And then determinant of 1, 1, 0, 0. And then this is 0, 1, 0. And then this one is 0, 0. And then 1 there. Okay. Okay. So this is negative. So you get, so this is equals to -1. And then we can delete this and this, multiplied by 1, right? And then multiplied by -1. We are deleting the first row, which is 1 plus 1, okay? And then determinant of 1, 0, 0, and 1, right? So this is 1, this remains -1. So this is equals to -1. And then determinant here is what? 1 multiplied by 1 minus 0, which will give us what? -1. Okay. Now, when you switch, you get a what? Determinant is a negative. Now, if we multiply by a constant, let's say R3, we multiply by, let's say 4R3. If we multiply the new, to get the new R3 here by 4, then our elementary matrix will be 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, and then 4, and then 0, 0, 0, 0, and 1. So what will be our determinant? Our determinant is equals to what? It's equals to 4, because we multiply the leading or the main diagonal. So the determinant is equals to 4. Determinant is equals to 4. Now, what can we see from here? So what can we see from here? Remark. Let's do a remark here. Remark. If we let E be an n by n matrix or elementary matrix, number 1, if E is obtained by applying Rj and the new Rj plus a constant multiplied by Ri to identity matrix In, where I is not equals to j, then determinant of E is equals to 1. Determinant of E is equals to 1. So the first one there, so when we added a constant to a new row, then when we find the determinant, you still get 1. Number 2, if E is obtained by applying Ri, when you switch an Rj, Ri and Rj to In, where I is not equals to j, then the determinant of E is equals to -1. When you switch the row, the determinant is equals to 1. Then number 3, if E is obtained by applying Ri, and then you multiply by constant, multiply by Ri to In, where K is not equal to 0, then determinant of E is equals to K. Determinant of E is equals to K. Then number 4, the elementary matrix E is invertible, and the determinant of E is not equals to 0.
So these are actually very important. So you need to remember. Have the elementary matrix. Let's say 4 by 4, 3 by 3. Elementary matrix is found by doing the row operations on the identity matrix. Okay. How is change at the constant, then the determinant will still remain the same. If you switch, the determinant will change, so that it one multiplied by a constant K on the row, you get the determinant is not K. It's not K. Okay, let's look at 1.1 theorem. Theorem 1.1. Now, if B is the matrix obtained by applying some elementary row operation to n by n matrix A, and E is the elementary matrix obtained by applying operation on the identity matrix In, then B is equals to E multiplied by A. B equals to E multiplied by A, and determinant of B is equals to determinant of E multiplied by determinant of A. Determinant of E multiplied by A. So if B is a matrix, we obtain some of the elementary operations to an n by n matrix A. E is the elementary matrix obtained by applying the operation on I, then B is equals to E. Okay, let's look at the proof on how we get into this. If we consider A to be equals to a 2 by 2 matrix, which is A11, A12, A21, A22. Consider that A to be that. So if B is a matrix of n by applying some of the operations to A is a elementary matrix. Now, the determinant of this A, is equals to what? It is equals to A11, A22 minus A21, A12. Okay. So that is a determinant of that matrix. You multiply this minus this. Now, case number 1. Case number 1. Now, if we do the row operation, if we now switch R1 and R2, if we switch R1 and R2, so if you switch this R1 and R2,
Then we get B. So we get B. So if we switch R1 and R2 in this A, we get our B. So if B is a matrix obtained by applying some elementary row operations to an n by n matrix A, so when we switch, we get our B. So B here is equals to A21, A22, A11, A12. Now, what will be our elementary matrix E? Our E will be what? The identity matrix in this case, I is I2, which is equals to what? 1, 0, 0, 1. So our E is equals to, we are switching also this one. 0, 1, 1, 0. So we are also switching. Now, let's multiply now this B and E. Let's multiply the B and E. Oh, so let's see whether determinant of B is equals to determinant of E and multiply by determinant of A. So let's see the determinant of E here. So what will be our determinant of E here using this? So when we switch, we get what? -1. So determinant of E is equals to -1. Now, what will be our determinant of B? Is this equals to A21, A12 minus A11, A22. That is our determinant of B. So therefore, determinant of B, so this determinant of B is the same as if we put the negative outside, so it's the same as negative A11, A22 plus, or minus here, minus A21, A12, okay? Right? So you can bring this negative outside. So it's the same as A11, which is this, A22 minus A21, A12. And this is the same as what? It is the same as negative determinant of what? Determinant of A, right? So it is the same as negative determinant of A, because this is like determinant of what? Determinant of A. Determinant of A. Therefore, it means that using this now, determinant of B is this. So determinant of B is equals to this, which is negative this one. So it means determinant of B is equals to determinant of E, which is determinant of E, multiplied by what? Determinant of A. Because determinant of E here is -1. Determinant of A here is what? Is this. So then we have proved that determinant of B is equals to determinant of E multiplied by A. Yeah. So that is how the row operations work. Case number 2. Case number 2. Now, if we add a constant, so if we add a constant, so if we add a constant, let's say we have our A to be equals to A11, A12, A21, A22. Now, if we do the row operation, let's say case 2, we take R2 plus CR1. If we take that, R2 plus CR1. So we get our B. Our B now will be equals to get the new R2, then it means A11, A12, and then to get a new R2 is R2, which is A21 plus CR1, CA11, and then the next one is A21 plus CA12. So that is our B. So that is our. Now, what will be our E? So our identity matrix 2 is equals to 1, 0, 0, 1. Okay. Now, our E now will be equals to what? We do the same thing here. So our E is 1, 0. We add. So when we add here, you get what? C, right? And then this other one is 1. The other one is 1. Okay. Since it is R2, the new R2 is R2 plus CR1. So R2 here is 0. So it will be C. And then the last one here is R2 1, then C multiplied by 0 is. Now, what will be our determinant of E? So determinant of E here will be equals to what? Is equals to? What is the determinant of E? So when you look at this, so this is 1 minus 0, which is equals to 1, 1. Which is equals to 1. So if you remember the past statement, yeah, when we switch or when we add a constant here, then determinant is still the same as what? 1. Determinant is 1. Now, what is the determinant of B here? So our determinant of B is A11 multiplied by A21 plus CA12 minus A12 multiplied by A21 plus CA11. So what do you get? So you get A11, A21 plus CA12, A11 minus A12, A21 minus CA11, A12. So what can we see from here? This and that's what cancels, right? So you get A11, A21 minus A12, A21. So our determinant of A is what? Is this. Determinant of A here is equals to A11, A22 minus A21, A12. Am I doing the correct thing? This is A22, if I'm not wrong. Right? Yeah. So this should be A22 here. So A22. So therefore, determinant of A is equals to determinant of E multiplied by determinant of B. Now, case number 3. Case number 3. If we now do the row operation, the new R2 we multiply by a constant R2. If we multiply by a constant R2, then we get our B. So to get our B here, then it is A11, A12, and then we multiply the new R2 by K. So K A21, and then A22 K there. So that is our B. So what will be our E? So our E is equals to 1, 0, 0, and what? and K. Okay. So our determinant of E here is equals to K, right? Determinant of E is equals to K. Determinant of B is equals to A11 multiplied by K A to 2 minus K A to 1 A1 2. So determinant of B is the same as you can factor out K A11 A to 2 minus A to 1 A1 2 A to 1 A1 2. Right? So then, yeah. So it means that determinant of B is this. So determinant of B is the same as K A11 A22 minus A21 A12 is equals to determinant of E is K. Determinant of A is what? Determinant of A is A11 A22 minus A21 A12. What? They are similar. So therefore, determinant of B is equals to determinant of E multiplied by determinant of A. Determinant of E multiplied by. So those are the three main important properties of a determinant. Okay, so look at the remark in this case. Remark. Now, since determinant of B is equals to determinant of E multiplied by determinant of A, since determinant of B equals to that, then determinant of A is similar to 1 over determinant of E multiplied by determinant of B. And this is similar to determinant of B if the operation, we can name this as OP, the operation is Rj plus C Ri, where I is not equals to J. Okay, that is what we realized. Minus determinant of B if the operation is Ri when you switch Rj, where I is not equals to J. Okay, and then E is equals to 1 over K determinant of B if the operation is Ri, the new Ri multiplied by a constant Ri, where K is not equals to 0, where K is not equals to 0. So those are the properties, the other properties. Now, if B is obtained by multiplying every entry in the ith row of A by a non-zero number K, then the determinant of A11, A12, A1n, KAI1, KAI2, KAIN, this determinant here, then AN1, AN2, A, N, N. We have that. This is similar to factoring out K here. We get A11, A12, A1N, AI1, AI2, AIN, AN1, AN2, ANN. So if the elementary matrix, the matrix which we get when we do the elementary row operations on A, we get these by multiplying by K. Then the determinant here is the same as we factor out that constant, which is K outside. Yeah. Multiply the K, one of the rows by let's say K. Then it is similar to the determinant. We factor that K. Okay. So our IRI is the same as 1 over K RI, where K is not equals to 0. K is not equals to 0. So we'll see some of the examples which are going to relate to this. Okay, let's look at example number 2. Example number 2. Compute each determinant if the determinant of A, B, C, D, E, F, G, H, I is equals to 2. Compute each determinant if the determinant is equals to 2. Now, number A. Now find the determinant of A, B, C, D, E, F, minus 3G, minus 3H, minus 3I. So what will be the determinant of that? What should be the determinant of? So which property can we use? Okay. We factor out what? So this is similar to factoring out -3, determinant of A, B, C, D, E, F, G, H, and I. And this one is what? This is 2. So this, the determinant here is -3 multiplied by 2, which is equals to -6. Number B. Find the determinant of G, H, I, D, E, F, A, B, C. So what happened here? What did we do? We did what? We switched R1 and R3. We switch R1 and R3. So using property number 2, when we switch, then what happens? Determinant changes to what? Negative. So this is the same as negative determinant of A, B, C, D, E, F, G, H, I, which is equals to negative what? -2. Okay. It's equals to -2. Number C. Find the determinant of A, B, C, D minus A, E minus B, F minus C, G, H, and then I. G, H, then I. So what have we done here? We have taken the new R2 to be R2 minus 1 R1, right? Right? So using the property number 1, then it means that this is so this is the same as doing what? So it's just similar to A, B, C, D, E, F, G, H, and I, which is equals to what? Which is equals to. So it doesn't change anything. Still need the same. Okay, now let's look at example number 3. Example number 3. Compute the determinant of 1, 3, 3, -4, 0, 1, 2, -5, 2, 5, 4, -4, and -3, -7, -4, and then 2. Compute that. Okay. So in this case, we want to draw reduce. So to make it easier, we can draw reduce this into what? Triangular matrix. Into triangular matrix. Into upper triangular matrix. So here, what we can do to get to reduce this one, so it means we can take the new R3 to be R3 minus 2 R1 to get the new R4, then it is R4 plus 3 R1. So what we get there is 1, 3, 3 minus 4, 0, 1, 2 minus 5, 0, 0, -1, -2, and then 4. Then we get 0, 2, 5, and minus 10. Okay, that is what we get. Again, we come and reduce this one and this one to 0. So again, to get R3, the new R3, get R3 plus 1 R2. To get R4, then R4 minus 2 R2. And what do we get? So we get 1, 3, 3 minus 4, then 0, 0, 1, 2 minus 5, and then here is 0, 0, 0 minus 1, and then 0, 0, 1, and then 0, then 0, 0, 1, 0. So that is what we do. Now, if you look at this now, what is happening here? See, this one is a determinant. Yeah. So what can we do? We can do what? We can switch, right? So we can switch. So when we switch, what happens to the determinant? It turns to what? So when we switch now R3 and R4, then the negative will do what? Will come outside, right? The negative will come outside. 1, 3, 3 minus 4, 0, 1, 2 minus 5, And then this one now will be 0, 0, 1, 0, and then 0, 0, 0, and minus 1. So it now becomes like that. So when you switch, then since it is a determinant, then the negative. Now you can do what? You can multiply the leading diagonal or the main diagonal. So finally, this is equals to -1 multiplied by what? -1. And this one is equals to 1. That is equals to 1. That's the simplest way. Okay.
So the first negative came from switching the rows.
Yes. So you switch the rows. So once you switch the rows, then it becomes.
Okay, and if we didn't have to switch the rows and the variable like this, it'd be -1, right?
Yeah.
Okay.
Yeah, and if you, the easiest way is to switch, but since you cannot multiply this, we still have a value here. For you to manage to get a determinant easily, then you can do what? You can just switch. So that it becomes what? Triangular matrix. Then for a triangular matrix, the only thing you do to get a determinant is to do what? You for the any questions? Okay. Example number 4. Combine the row reduction and the cofactors expansion to compute the determinant of -1, 2, 3, 0, 3, 4, 3, 0, 5, 4, 6, 6, then 4, 2, 4, and then 3. So you can row reduce to the point whereby you can also use the cofactors. So, okay, so what you do here, looking at this, yeah. So if you look at the second row and the third one, so you can actually make this one, you can make this to be 0 to the point whereby you can create as many zeros as possible on the row for the column. So you can do the row operation on this to get zeros or one of the zeros here. So what you can do is you can subtract the row 2 minus row 2 minus row 3. So this and this will be one of them is 0. After that, you can also do this and this. You make the other one to be 0. So this can be 0. So you realize at the end of the day, this will be 0. Then you use the cofactors. So when you use the cofactors again, you delete this and that, you this and this and that. So then again, you do the same thing. So when we meet the next time, then we can do so. Okay, I will pause the homework, but it will be due the other week, the other Friday. So it's not a must to do it this holiday, so you can relax. Don't spend more than 20 hours this week, okay? Thank you.